So in the previous video, we get Olama and we downloaded small language model, and I tested Q1 2.5. And now we'll move on to using LangGraph to finalize, to develop chemistry agent. LangGraph is a library developed in langchain, and it's for easy development of large language model application. So it provides many good tools to easily deploy chatbot or RAG, like a RAG stands for Retriever Augmented Generation. Maybe a good example is Perplexity, which searches information to give a better answer. And langchain is really nice because it can easily connect all different language models. So that's why many people working on language models are using langchain. And we are going to use LangGraph. So it's for developing agentic system. And here you may notice that it was chain here, and now it's graph here. And this graph is actually workflow. So LangGraph defines workflow graph to guide the model behavior. And we can include the tools in the graph, in this workflow graph, so that user-defined tools will be added to this workflow. Then model, the model connected to this workflow will follow the state saved in the workflow graph, and when it's necessary, it will use user-defined tools. I have prepared template for this hands-on session, and I obtained it from this LangChain Academy. You can access all these materials, and here LangGraph session provides all the codes used in this program. Actually, it has 8 modules, but I only use module 1 in this hands-on session, because I think it's enough to complete module 1 to develop chemistry agents here. And in the original material, it uses ChatGPT. So it's working based on OpenAI API. And I just modified this part to use Olama installed in your laptop, so that we can develop agents that can run in the local environment. And also, using open model doesn't require payment, so no charge, but still you can make good agents. Okay, to summarize, you're gonna complete 2 tools. So everything is completed in the Jupyter notebook. You just need to read the code and understand how it works. And there's one cell where different tools are given in the example code. You just need to replace that cell to the tools you need to give to the model. So model should do the 2 different tasks. First, user ask a question, like in my previous video, the question was that, does Tylenol satisfy the Lipinski's rule of 5? Then what it needs to do is the model first identify the name of the chemical, and then find the smart code using TokenPy. And then once Mars code is retrieved, it will be used to check compliance of Lipinski's rule of 5. So you need to calculate molecular weight, log P, hydrogen bonding, donor hydrogen bonding, acceptor with RDKit, so that the model will give an answer like this. Actually, this answer is taken from my code, which is already completed. So once I give all the tools, these two tools, and I ask about the if Tylenol satisfy Lipinski's rule of 5 or not, then it gives answer like this. So the Lipinski's rule of 5 for Tylenol has the following values. So the compliance is true. And I did it with Q1 2.5, 0.5 billion model. So this is what we are going to do in the session. If you think it's too easy, and when I prepared this, I was afraid that maybe my hands-on session is too simple. Maybe every student can finish all of that within an hour. So this is additional challenge. If you think the previous task is too easy, maybe you can go further to make your agents optimize the 3D structure. You can do that with RDKit. Or you can make your agent to run the QM calculation, quantum mechanical calculation. MOPAC is quantum mechanical calculation software, which was commercial before, but now it's became open source in Anaconda. So you can download in the Conda Forge to run the QM calculation. And MOPAC is a semi-empirical model. So it doesn't take really long computation time. You can finish QM calculation within the reasonable amount of time. And also Vina is now available as a Python library. So you can make your agent to run the molecular docking if user provides name of chemical and protein. My initial plan was to doing this one, but I wasn't really sure. Every participant have experience of running molecular docking, and also you need to go through simple pre-processing step for the protein structure to run the molecular docking. So if you're interested in, maybe you can try later. And I know AI chemist students are developing their own model, and maybe you can deploy your model later in the chatbot system by developing your own agent. And if you give a tool to call your model based on the user prompt, then you can deploy your model in the chatbot interface. So that's it for the lecture, and now we'll move on to get our hands dirty on the code.